Welcome to 10,000 parcels a day, how Swiss Post controls sorting from the cloud. Now, this being the Zurich Summit, I assume that most of you in the audience are actually living in Switzerland, and then you have dealt with our postal services, right? And for us as end consumers, if I'm sending a parcel, I only have two touch points, right? It's when I hand over the parcel, and then something happens, and at some point, that parcel suddenly gets delivered or shows up at the door of the recipient. Now, you can probably imagine that in between that, there is a lot of processes that happen, a lot of physical things that happen to get that parcel to the door, and also a lot of IT processes happen. And one of them is sorting. Now, in 2020, Swiss Post has started a project where they tried to migrate and modernize their existing sorting solution to the cloud. And I assume you're here because maybe you also have a legacy system that you want to modernize and that you want to improve upon, and you want to learn from us a few of the lessons learned and a few of the takeaways. Now, who are we? I'm joined on stage by Mark Saller, the solutions architect from Swiss Post responsible for package sorting, and I'm also joined by Simone Quignola, the AWS cloud architect from Swiss Post, and my name is Marcel Neidinger. I'm the account solutions architect for Swiss Post from AWS. Now, the title says 10,000 parcels a day, but I already have to tell you that there is a small error in the slides. And that is because back when we handed this session in, it actually were 10,000 parcels a day that were sorted by this solution. Now we are at 300,000 parcels a day. So the correct title of the session should actually be 300,000 parcels a day, how Swiss Post controls sorting from the cloud. I hope you can oversee that, but let me hand it over to Mark to give us some more insights into the sorting process, into the requirements, the architectural requirements, and how that actually works from a business perspective.
Thank you, Marcel. So let's have a look at parcel sorting at Swiss Post. First, we start with a few numbers. At Swiss Post, there are different companies within Swiss Post, and one of them is Logistics Services. Logistics Services in 2023 had 21,000 employees working for this branch, and it makes it the biggest branch at Swiss Post. Within Logistics Services, there is Logistics Service Operations, which is responsible for, in German, it's Annahme, Sortierung, Transport, Verzollung und Zustellung. So the process we simplified with this parcel. So it actually fulfills all the things behind the scene that is necessary to bring a parcel or also a letter from A to B. We sort around 800,000 parcels per day, which is pretty impressive in my opinion, since we have around 8 million citizens in Switzerland. And our biggest peak was during COVID, where we sorted 1 million parcels per day. So, but what is sorting, and why is it not so straightforward like we did it with the parcel before? You see here the business process, and there are essentially 4 steps that are done for every parcel that is sorted. We start with the first step. What we do there is when you put the mail piece onto the sorter, we take a picture of that mail piece. We do a region of interest recognition. You see it here with the green boxes. We figure out what's on the parcel. That's the address, for example. For the address, we do a OCR coding, so we know what's written on the parcel, and we also read barcodes, QR codes, and whatever. If we are lucky, we have already this data, and we find the data that was delivered before to Swiss Post from a sender by using this barcode. Then we need to figure out a few more details about this parcel, and especially about the person that will receive the parcel. Swiss Post do something special when compared to other postal services. We really figure out what person will receive the parcel, not just the address. That makes it possible that we can send to you a notification, you probably got this email already, and that you can control one of the parcels you get or all of them. So for example, when you moved to another flat. Of course, for a person there is always an address, at the end we use to deliver that parcel. There are other things for a parcel. For example, is it economy or priority? What are the dimensions of this parcel? And a lot of other things that could come into play. From all this information, we figure out when we will actually deliver the parcel to you, that we can take into account the correct services. And with these services and the predicted delivery date, we figure out from the so-called delivery plan who will actually deliver the parcel to you and how this is going to be done. When we have that one, with the sorting plan, we figure out to which slide from the sorter, from the parcel sorter, the parcel will go down. Then parcel is sorted. We do parcel sorting with different sorting centers in Switzerland. You see the 2 yellow dots. Actually, those 2 yellow dots are for 3 parcel centers. The yellow dots are parcel centers that are already migrated and running with the new software system. The others will follow this year. We started like 2 years ago with the first pilot where we used this new software together with a freshly installed parcel center. So there were a lot of things to tune, not only our software. And a while ago, or like a year ago, we started the sorting for about 10,000 parcels a day with this new parcel sorting. A few weeks ago, we migrated Vetro, and this week we migrated the biggest parcel center in Switzerland, Herkingen. So far, we sorted around 6 million parcels with this new software. Now, an important aspect is why this project was started or why the current software wasn't enough anymore. Here are a few high-level business requirements that we translated into architectural requirements and also architectural tactics. Most of the points, let's be honest, are the same for every software system. Nevertheless, I want to highlight some things there in the requirements. So the development, maintenance, and operations was very expensive. So we had a lot of people just running around for operations, doing a lot of manual things that could have been done automatically. And also development and maintenance was very expensive. So we were not really agile. And the business was not enabled by the software, but actually disabled, which, well, we cannot allow that way anymore. Then, of course, faster time to market. When we started to work on that project, we had all 6 months a deployment with new features and fixes that had to be rolled out for whole Switzerland, so it took probably 2 weeks. So now you can imagine there is a really long time to market, and we want to be much faster there. Of course, also more flexible, because just because you have a fast time to market, that doesn't mean you can implement new business requirements as the change requires it. Then we have a lot of different vendors in the parcel centers from different sorters. So the newest thing is probably that we have robots driving around that can be installed pretty quickly. And we want to support also more vendors and to be able to integrate them faster. A very important aspect was the flexible deployment architecture. So far, every parcel center has an own server room with hardware, with virtualization, and the software running on top of that. So that makes it very expensive in terms of maintenance and operations. The reason was that the business wanted to be able to also sort when the central data centers of Swiss Post or the network was down. We decided that this isn't necessary anymore as we have enough backups, and we create the system that is able to handle all the centers centrally, but that we can also deploy again on premise or into a parcel center if that becomes necessary in the future. So that was a big thing we couldn't do with the old system. Last but not least, it's very important to be very stable, so be available 24/7. The system so far was very stable. However, there were always maintenance windows to restart software services, to install updates. And we wanted to move away from that and just be able to deploy with zero downtime and without a maintenance window. How did we plan to achieve that, or what did we do? There are different points. I will not go into every of that point, but highlight a few things probably interesting. So the first point, as I said, there was a lot of manual interaction, so we really spent a lot of time to rethinking processes and to design how we can do that directly without steps in between emails, Excels, whatever, but with a direct integration between source and target systems. We pushed hard for a DevOps model, so we just wanted to have developers on our team responsible for developing, maintaining, and also operations, no other roles. Of course, we had some business analysts to help with the first point. To achieve flexibility, we decided that we want to deploy our whole workload as containers, or at least to be able to if that becomes necessary. We integrated asynchronously only, so only over Kafka, that our system is able to run independent of the rest of the systems and the infrastructure. We decomposed according to the change rate. No further words about that. You will see the decomposition later on. We pushed for continuous deployment from the beginning so that we are able to roll out while the sorters are running. We applied chaos engineering also from the beginning and tuned our proactive monitoring. Our goal is to figure out when something goes wrong within 5 minutes and before we get a call from a center telling us that the parcels don't get sorted anymore. And that one about the integration from the other vendors, we introduced a MQTT broker. MQTT is a PubSub protocol widely used in IoT scenarios and modern APIs with JSONs so that we can flexibly integrate new vendors and also being able to have migration scenarios. All those things also mean we have requirements to the platform because we can only be operating 24/7 when the platform is also 24/7 available and so on. So first of all, it was interesting that we had a cloud-first strategy and logistic services strategy was to go for AWS if there is no strong reason against it. So we aimed at that and started discussions whether they can handle our workload and all the things are there which are necessary to fulfill our requirements. One big thing was we must not have a cloud hosting vendor lock-in. I talked already about this deployment model. And if we want to go on-prem whenever we have to or into a center, it must be possible to do that without using services that are only available on AWS. Of course, we need high availability and stability. Very important for this DevOps approach, low cognitive load, so it must be possible to do a lot of things in self-service. You see it at the bottom, preferably with infrastructure as a code, while still having a low cognitive load to be able to handle this all by yourself. Also very important was that we were not restricted in terms of technologies so that we can use the right tool for the right job. Now I hand over again to Marcel that he can show us the building blocks in AWS.
Yeah, thank you very much, Mark. And to continue, we're going to split this into 3 different parts now. So I'm going to start by introducing or giving you an introduction of the AWS services that were used. Then I'm going to hand it over to Simone, who is going to talk about how they are packaging AWS as a platform that DevOps teams like the one from Mark can use. And then finally, we'll get back to Mark to tell us how to actually implemented this new sorting decision system on AWS and on the Swiss Cloud Foundation, the Swiss Post Cloud Foundation. So let's get started with a short introduction to the AWS services. And we're going to roughly map them always to the architectural requirements or the platform requirements that Mark has mentioned. And the first one is something that we kind of always take for granted, that we say, hey, we have APIs for everything, right? We have a service at the bottom, and then we have this common API. We have SDKs from the different for the different languages, and you as a client can programmatically and automatically interact with all of these APIs. Think back to the requirements. We want to lessen the burden on the cognitive load on the DevOps teams, and one of the best ways to do that is automation, right? And besides just calling the API to create resources, to update resources, we can also use intermediaries like, for example, Terraform in order to do this in an infrastructure as code method. So it's another thing that the Post has done quite a lot of use of, where they say, okay, we want to have reusable components, we want to have reusable patterns, and we want to have everything in infrastructure as code, where on the left I have the code that essentially creates a load balancer in AWS, and then I have the Terraform provider handling all the CRUD, the create, read, update, delete operations, and maintaining the state, and also handling the interaction with the AWS API, so that we can really automate the entire infrastructure automation and the entire infrastructure rollout. So we have a technique to provision our resources. Now we need resources to provision. The first thing we need is a compute platform, and as Mark has mentioned, they really need something containerized, and they opted for EKS. So Amazon EKS, or Elastic Kubernetes Service, it runs vanilla upstream EKS in a managed mode. So we track the upstream EKS version. We provide you support for up to 4 Kubernetes versions. Gives you the ability to update in stages, but it does provide you with a managed Kubernetes experience. What does that mean? Well, we essentially split things up into 2 parts. On the top, you see the AWS managed control plane. So this is a single tenant, highly available Kubernetes control plane. This is things like the API server from Kubernetes, or this is things like the etcd deployments. And these are managed by AWS. And what the customer manages is the data plane, so the lower part in the customer VPC, where you have different options of how you want to provide the compute capacity. You can either go with self-managed EC2 instances, or you go ahead and you have EKS managed node groups for you. You can use open source tools like Carpenter to do auto-scaling and dynamic allocation for you, or you can use serverless options like Fargate in order to do this. And by that, thinking back to the requirements, we take away the heavy lifting, right? Like the operational burden of operating a production-grade Kubernetes cluster, while giving you the flexibility to just use vanilla Kubernetes at the end of the day for your containers. Now, one of the way that looks like is we have the 3 availability zones, and we have our worker nodes, right? This is now the customer perspective, how this looks like. Now, from a networking perspective, we also have a very good integration into the VPC networking, where we can let on our worker node our different pods communicate as if they were just running within our VPC via this CNI plugin. It's an open source plugin from us, the Kubernetes CNI plugin. They essentially just get an IP address and can communicate that way. Now, one of the most common things that we see with these kinds of migrations that we also saw in this project is you get a team like the one from Mark, who's really happy to go and to modernize and who has the resources to modernize. But usually it's not just a single system that exists in itself, right? It usually communicates with a bunch of different other systems, and we sort of need a way to not have to migrate the entire system landscape, but be able to do one thing. And this is then where we can, of course, do something like EC2 to lift and shift VM virtual machine images up to the cloud, and then slowly but surely migrate these adjacent services. Maybe these are vendor-provided services or vendor-provided software. We can slowly but surely migrate them to the cloud or modernize them at our own pace, without having to constantly, go do a round trip to the on-prem environment, of course. So we have compute. We need a database. This is where they have opted for Amazon Aurora. Again, the Postgres variant, and Aurora, again, is a managed service. So for relational databases, it's compatible with both Postgres and MySQL. In this particular project, it was Postgres. And it's a managed service. So AWS, again, handles the administrative tasks, hardware, patching, getting all of these backups in place and things like that. And you can concentrate on actually using the software without having to do the operations part. As you've seen in Mark's introduction, that was a big driver, right? They wanted to lower that cognitive load without locking themselves in. So data replication and automation backups are there. And we do have a multi-AZ architecture. Call back to the availability, right? This needs to be running 24/7. So this multi-AZ architecture means that we can typically fail over in less than 60 seconds. So adding it to our architecture, we have 3 different PostgreSQL Aurora instances in here, 1 being a writer and 2 read replicas. just talked about availability and about resiliency, and that it's great that we have all of this and we have checked all the boxes, right? Or we have written all the Terraform code to actually check the boxes for us. But how do we actually test this? How do we make sure that this actually works? And this is where FIS, Fault Injection Service, formerly known as Fault Injection Simulator, comes into play. Again, a managed service for chaos engineering. So the idea with chaos engineering is that we artificially inject issues into our system to check how they would, essentially behave in case this actually was happening, right? We do a hypothesis. We have this hypothesis that our database is deployed in such a way that it can handle the failure of 1AZ. Okay, let's test that with an experiment and see if the software really reacts the way that we want it to react, right? We can inject network issues, we can inject pod stress, database failovers, all of these kinds of scenarios, and that really allows us to verify the resiliency and the recovery plans that we have in place and that we have set out to achieve with our architecture. So we can add it in here, right? We can just go ahead and shut down a database and trigger a failover. Or we shut down an instance and see how the self-healing of the instance works, how they can be spun back up, or if the other instances are able to handle the load. Or we go ahead and we just, for example, disconnect the lift and shifted part and see how the system is actually handling that, and also how the processes in the background, things like paging, things like operations involvement, do actually behave in this environment. Now, we do also want to use other AWS services, like, for example, Amazon S3 for file storage, pictures of packages, for example. So what we can do is very easily, with a very simple setup, so that the developer doesn't really care about what is happening under the hood, set up the SDK with IAM permissions to be able to interact with different AWS services. And S3 is just an example here. And with instance profiles, we can do the exact same thing for the EC2 instances, right? So that we can have them just, the developer doesn't need to care about what is happening underneath with the cloud itself. Again, lessening the cognitive load and making sure that the developers can develop and not spend time on the infrastructure. And then Mark also mentioned that they want to be able to use a broad range of technology, and sometimes maybe you opt for a third-party SaaS solution that you can then at the same time still procure via the AWS marketplace. Then you see the SaaS is not running in the customer account, but it's running in the SaaS vendor's account, and we just do a private link connectivity to that specific SaaS provider, so that you can then consume the service from them. So that's a broad overview of all of the services that we're using, so it's sort of the building blocks that you can use. So Simone, go ahead and tell us how you're packaging them up as a platform for DevOps teams.
Thank you, Marcel. Welcome to this session also from me. And in the next few slides, I want to show you how we have this cloud foundation concept and how we package AWS as an internal platform. So let's begin with some dates, because this journey didn't start from yesterday. It actually started in 2014. And it was mainly to understand cloud and how it applied to the Swiss Post. This led to 2017, where the cloud has been defined as strategic enabler for the Swiss Post, with the direct result that in 2018, we created the cloud foundation with the duty of building up the landing zone so the DevOps teams could work on it. The latest milestone in this journey is the establishment last year from the Post to Cloud project. Here the goal is to assess all the on-premise workloads and move them to the cloud by 2027. But what is it, this cloud foundation? So as Mark and Marcel said, the goal here is to reduce the cognitive load for the DevOps teams to go to the cloud. And we can split them in 4 different areas. The first one is, as I said, we package it as an internal platform. So you order your account with internal toolings, you get billed through internal toolings, and for as far as the DevOps team is concerned, everything is internal. This still allows them to use every AWS services they want to explore. One of the key points here is that we also use this shared responsibility. So to ensure a safe usage, we have to work together, the DevOps teams, the foundation, and AWS, to do everybody's part. The second area is governance. So here we are mainly talking about putting in place the guardrails on the landing zone so that the DevOps teams can use it in a safe way. The second point is that we also support the teams on their journey, not only on the technical part, which is the main part, but we also then with the procedural part, because we know what kind of paperwork needs to be done, and we are there to help them to go ahead. One of the other important steps is that we act also as an intermediary between the team itself and the other infrastructural team of the Swiss Post. Because in the position that we are, we can speak the same language to both parties and smooth up the adoption of the cloud journey. The third area is the bread and butter of the foundation, so actually providing the base infrastructure to the teams using it. Here you can see it already from Marcel and Mark, the keyword is infrastructure as a code. We try to stay away as far as possible from clicking through the console, and everything is documented in Git. The cornerstone of the foundation are the shared EKS cluster, because these allow a team to quickly deploy their workload on the cloud, and for us as foundation to have an easier governance over the workloads that are there. The third point is connectivity, another crucial point, because you saw this is a long journey. We are moving applications, and every application needs to connect to its own interfaces, and they don't care if it's on-premise or on the cloud. We just have to make sure that they can do that. The last part is that we have such a low friction that teams expect every new service to be available in the foundation. So we really have to let this technology flow inside the foundation to be used. The last area is some kind of the second soul of the cloud foundation. So we just don't need to build a platform. We also actually help the people to work on that. Here, as we can say, AWS is providing the services, the APIs. We use Terraform for infrastructure as a code to deploy the resources there. And as foundation, we provide the modules that can be picked by single teams and used to deploy their preferred services there. Another important role that we have is the Cloud Buddy. And here it's meant to provide the know-how to a team that is starting its journey in the cloud. And lately, we are also using the Cloud Buddy to investigate new services where maybe the single team doesn't have the know-how or can't understand the full complexity of a new service. The last part is really we try to be as much as we can on the customer-driven feature request. This means that we want the people using the foundation to come to us and tell us what they need. In the crowd here, you can find the product manager and the product owner of AWS, and they can tell you how much fun it is to juggle around with priorities when you have this. But this is what we want. We want the people telling us what they want from the foundation. But, OK, how does it look like on the technical part, the foundation? We start with this huge empty box, which is AWS, and we draw some kind of logical domains into it that help us to keep some tidiness. The first one is the management domain, so you can think about the organizational tree, billing, reporting, that kind of stuff, and somehow self-contained. The core part for the foundation is SaaS. So this is the core domain, auditing, monitoring, networking. This is the part where we work on, where we improve it, and we ensure that all the landing zone is running smoothly. And another key point here is that this part is fully abstracted away from the teams using the foundation. The customers come into play first in the sandbox domain, and this is meant to be some kind of relaxed environment where a team can do research and development, trainings, or test ideas. But the real meat is in the customer domain. Each service that you see here are not managed by the foundation. It's the DevOps teams that they need them for their own application, and they deploy it in their accounts. As you can see, this is just really a small subsection. We have almost everything from compute, storage, databases, machine learning. If a team needs it, they are free to use them in the foundation. The latest addition that we had in the last months is the SaaS domain, here in the shape of MongoDB Atlas and Confluent Kafka. And this is not just creating a VPC endpoint private link to the service that we want to use. It's doing that and do it in a way that it's safe and easy to use for the other teams. But where are we now? And 2 years ago, I actually did a similar talk at this event. And we were presenting the foundation, and we were facing or working with the early majority. Now it's 2024. We somehow crossed this adoption curve. We are working with the late majority, so a new segment of the developers of the Swiss Post. You can also see the numbers. We almost doubled them. Could we hope for more? Sure. Are we happy? Yes. Still, it's a journey, so we don't have to rush it to the end. This means that as a platform, we are still working to improve it, even if we have critical workloads like the one that Mark is showing you now. We also have to find some kind of balancing act between the new feature requests coming by and doing maintenance. At the scale that we have, it's quite easy to iterate limit on AWS that force you to rethink how you implemented something. And the last point, we also resort to assessment, because these ones are the ones that give us an idea of the blind spot that we have on the foundation. And let's switch to the second part, the second soul of the foundation. We are also working as consultants. And as you can see, we are working with different segments. Now, in the first half of the curve, you're working with people that want to go to the cloud because that's fancy. Now we are working with people that go to the cloud because that's part of their work. This requires really a different mindset. We have to change it. We have also to change the way we train people to use the cloud. And maybe the last key takeaway that I want to give you is that we really have to design the system for average employees, because they are average by definition, and they are the ones that need to use it easily. Rock stars will find somehow a way to work with anything you throw at them. In this last slide, I want to share you some current and future challenges that we have at the moment, because I think if you go on the foundation way, which is a great model, maybe you can foresee these issues a bit before and act. So on the technical part, as I said, we are building the landing zone while the people are using it. Then you have something like GenAI coming by and you have to stop, think how it fits, go ahead and start continuously building that. We are also working on improving the governance. And this is not really internal to the foundation, but as I said, it's to help teams that have to go through the same process. And from our point of view, we can see how we can streamline that. So we are there to help them. We also have to assure resiliency. Here, the key point is like lowering the number of moving parts that you have in a foundation. It's not really a good, easy or good exercise. It takes time and it takes trial and error. But at the end, you have to ensure that everything works smooth 24/7. Last point, we provide the blueprints that I said before. We provide the modules, and we want to solve them specific problems so a team can pick them as Lego bricks and build up on top of it. On the human side, this one I said, we are working with the late majority. We have to upskill them, and it's not only doing the training, you have to do it correctly and at the right time. Too early or too late, and you wasted also the whole upskilling process. By going on with this journey, we also have this know-how gap between teams. So in a day, you can go really full bipolar, working with Cloud 101 with one team, and then working with another team that is using in a service that they know better than you, because they have really a vertical knowledge on that. We are also including more and more IT roles in this journey. Here, the difficulties are on speaking the language. Now, each new role has its own language. You have to speak to them to let them understand what we are doing and why. And the last point, which is a bit a subset of the previous point, is we really have to improve the FinOps awareness. And this is not providing alerts or fancy reports. This is letting the teams creating their solutions on the foundation understand that they have a direct impact on the expenses. So, having said that, I wish to give back the word to Mark so he can show you how he built it on top of the foundation.
Thank you. So, as you can guess, we finally decided to go for Azure. No, just joking. Of course not. You saw that all the components are there to build our solution on AWS. So we started the journey there. We were never disappointed and looking forward to roll out the whole parcel sorting to AWS this year. Here's the decomposition of our system and where the components are deployed. Each blue box is a so-called, or at least 4 blue boxes in the middle of the picture, is a so-called software solution. That's the thing we call to group software services, so one purpose, or that's the name we use at Swiss Post. So behind every blue box there are multiple software services, and we use this flexibility to increase resiliency, to do migration scenarios, or whatever is necessary. Let's go through those building boxes and start on top. All those 3 software solutions or the services are hosted on EKS and use a SaaS service. More about the technologies behind it later on. We have first the sorting decision system support. We need two things, not essentially for sorting, but as a preparation and as a reaction. We stream a lot of data in, and for some data we need to do validation, group them differently together, mix some other data sources in to get them prepared for parcel sorting, so that's part of this box. And we also have some operational change that needs to be necessary. There are a lot of surrounding systems. In theory, we could just change data there and stream it into your system. However, not every team is 24/7 on call. So we have certain scenarios we have to provide 24/7, and therefore we have this applications for operational change. And that's also the only UI we have in the system right there. Then in the middle, the sorting control system is the heart of this solution. It essentially controls the sorting, and it do so by using this Anlagentechnik gateway for historical reasons. This name is in German. In between this box there is a MQTT broker cluster and also other services doing some protocol translations. As you see, the Paketzentrums on the right, the three blue boxes at the bottom, they are using a protocol called PP2000. That's a TCP text-based protocol we still have to maintain, so we do some translations there that we can have the modern API behind it. And also the other communication here, a little bit misleading with the arrows, are going over this MQTT broker. So all we do with regards to translation and towards stuff around this protocol is in this box. Then we have the box at the bottom, the coding system. This component is from a vendor from the Netherlands. That's the thing that is responsible to do the OCR stuff and to figure out the person that will receive the parcel. So remember the first step in the chain. There we still have Windows VMs, so we have to host them on EC2, and we're working with them together to also move towards containers. So we'll do the first proof of concept, or the first installation actually, from half of the system, I would say, the half of the system components end this month, so that we can shift eventually all the things to EKS and use the same stack. Here you see the technology behind all those things. On the left side, as I mentioned, you see that we integrate all the vendors inside the parcel centers using MQTT and or protocol, and all the other things are integrated using Kafka or central Kafka platform, so that we can fulfill this async integration and be up and running no matter what other systems do. Then the first thing, the sorting decision support. As said, that's hosted as container. All our solutions, all the code we wrote here is written in C# and .NET, the newest version, .NET 8. Not sure everybody knows, that's a new world, not Windows anymore. It's hosted in Linux containers, and it's pretty fast. So I looked it up yesterday. We use currently 1 virtual CPU and 3 gig of RAM for sorting 300,000 parcels a day. So pretty efficient. And we have also good developers, by the way, but it's possible to do such things with this technology nowadays. The UI is written in Angular, and we are using TypeScript. For all our systems, by default, if there are not special requirements, we use Aurora Postgre with serverless instances, so we do for the sorting decision support. The Anlagentechnik gateway, there are some services, and I mentioned the MQTT broker or the cluster. We host that one as containers by ourselves on AKS as well, and we use the product EMQX there because there are some enterprise features like Kafka connectors, rules, etc. we use for migration, but also for some specific integration scenarios. Also their persistency is done using volumes and also PostgreSQL. The coding system, as mentioned, still on EC2. And there we have also MS SQL servers running, a few clusters. We use RDS there, so no problem to run it on AWS. Also there, we will shift towards the same stack as we use internally for our self-created software. There we have also Amazon S3 in place, also a very good thing because we need that to exchange the pictures made in the centers. And there are a lot of old components. When we are lucky, they support encryption. Sometimes they do not, but what they do is FTP support. So we went for S3 that we can have SFTP or FTP SAS, but use a more modern protocol behind it and do further stuff. Then the heart of the system, the sorting control system, also written in C#. There we had a special demand. We wanted to use a document DB and we wanted to use MongoDB. The reason there is that, again, we want to host it as container if necessary on-prem. So that's possible with document DB. And also we have specific requirements with regards what we do on a document level that was not possible to have with Postgre and the JSON support there. There we use MongoDB Atlas, and thanks to our foundation and thanks to the AWS Marketplace, it was pretty easy to integrate it and to use a VPC to connect it to our software system. So let's go to the conclusions. I have you two perspectives, the more DevOps or technical perspective and also what's in there for the business. Today we have 15 developers. One of them is sitting here, so if you want to hear the truth, not what the architect tells, you can ask him in the break. Luckily, important to mention, we were able to hire a lot of new developers. Most of them either changed internally at Swisspost or we hired them from external. And we hired with the idea of DevOps in mind. So they are all very happy to be on call 24/7 to run their shit. And they are also having a shared quality mindset, which is really, really important that we were able to build that. We have also 2 product owners and 3 business analysts embedded in the teams, helping us with a lot of processual work that we can build a meaningful solution. We have also 3 solution architects, so myself and 2 colleagues embedded in the team. By the way, we also are on call, so we do the same as the devs also do. To date, we have 5,000 deployments since we were productive. In comparison, the existing system in the same time had 5. So there's pretty more going on or more flexibility. As said, we are 24/7 on call. So far, we consider it as a success. Most calls we get are because of other parties and not because our system fails. So we're working on that as well. We are pretty stable so far. We had, unfortunately, 1 change failure, so something, or we took a center down actually after deployment. Happened once. It took us 1.5 hours to restore. We are not happy. Nevertheless, it's also much better than what we had with the current system and this release process, because it often meant longer time offline and more bugs than we currently have. So we took measures that this will not happen again. It was like a year ago, I guess, so never happened so far again. So we consider this as a big success, and we're looking forward to the upcoming years to prove that it also works in operations and after the project ended. What's in there for the business? Some numbers are extrapolation, so let's see whether that will be like that at the end. Nevertheless, what I can say, we estimate that we will have a reduction of 90% infrastructure costs once we migrate it. We estimate that we have minus 1 million Swiss franc costs for manual interactions we had, so stuff that it's not necessary anymore to do, mostly for operations. We achieved with architectural measures to have no vendor lock-in, so we can still, within, we estimate 1 or 2 weeks, go on-prem, host the stuff by yourself, while we still have huge benefits of using SaaS services at AWS and being like cloud native. We do all those things by still maintaining a high pace, so not only deployments, but we are today able to bring in average a commit to production within 1.5 days. It's not that our pipeline is slow, it takes us around 10 minutes to deploy to production once something is into the master branch, but this average commit lead time is when a developer starts developing locally, makes a commit until it goes through the code reviews and is on production. So we can be faster if it's necessary. Now during the rollout we have often fixes we have to ship within 20 to 30 minutes for something they discover in operations which was not specified like that. We streamline the processes. As said, we can now stream master data to sorting within minutes or seconds if the systems publish that fast. So far it took like 2 weeks until an address reached the sorting system when it was changed in the source system. So a big advantage also there. And we also have no maintenance windows, so we do all the things while we are online. MongoDB cluster updates, Kubernetes cluster updates, or also deploying our applications. So also here, we hope, assume, and actually we know that the business is happy so far. Now for the closing, back to Marcel.
Yeah, thank you very much for listening. Thank you very much to Mark and Simone for presenting. You have heard this, the number of sessions you have been here. Please go in the app and give us a feedback in the survey. You can either just search for post or you can search for BIZ301, which is the number of the session, however you prefer. Our email addresses are here. We are around if you have any questions, and thank you very much for listening.